Today, I will present our work, Music to Dance Generation via Atomic Movements. The task is music to dance generation. Given a music sequence, the model generates a synchronized three-dimensional human dance sequence. Most existing methods treat motion as one continuous signal. This overlooks the compositional structure shared by music and dance. As a result, generation is difficult to interpret or control. Repeated music phrases like meaningful, choreographic, variation, and transitions may be neither smooth nor rhythmically consistent. We address these issues with two contributions. First, we discover interpretable atomic movements through segmentation, clustering, and LLM-based refinement. Second, we introduce a two-stage generator that first plans atomic movements and then completes the transitions. This improves structure, rhythm, and controllability. Our starting observation is that a complex dance can be represented as a sequence of atomic movements. Each unit forms a complete process, can recur with variations, and has a clear semantic meaning. The discovery pipeline begins with segmentation. We divide continuous motion into process-complete units while preserving the semantic integrity of each action. These segments become our initial candidates. Next, we cluster semantically similar segments. A cluster captures one reusable movement pattern while returning natural variations in style, range, and duration. However, visual clustering alone can still make different actions. We therefore use an LLM to analyze movement descriptions and split coarse groups into finer semantic categories, producing more interpretable atomic movements. Using these discovered units, we build our two-stage structure-aware framework, atomic movement planning followed by dance completion. In the first stage, the model performs music-aware choreography planning. It selects and arranges an atomic movement sequence and predicts when each movement should occur and how long it should last. In the second stage, the model turns this plan into continuous motion. It diversifies repeated movements, bridges neighboring units, and refines the result to create smooth, natural transitions. We evaluate on AIST++, which contains 1,408 music motion pairs, totaling 5.2 hours across 10 dance runners. We measure motion quality with FID, diversity with diversity and multimodality, rhythmic synchronization with beat alignment, and music motion structural consistency with R precision. The quantitative results show that our method achieves the best overall performance. In particular, it obtains the lowest FID scores and the highest R precision while maintaining strong beat alignment and diversity. This demonstrates better motion quality and stronger structural coherence. This ablation validates atomic movement discovery. Too few clusters merge distinct patterns, while too many fragment similar movements. LLM-based reclustering gives the best results and makes the categories more interpretable. For dance completion, simply fixing retrieved movements limits diversity, allowing atomic movements to be flexibly refined produces both higher quality and more varied dances. We also compare retrieval strategies. Fixed retrieval lacks diversity, whereas random retrieval damages structural consistency. Retrieving by the nearest duration gives the best balance of diversity, realism, and temporal compatibility. Qualitatively, previous methods often generate isolated poses or over-smoothed repetition. Our method generates complete movement processes. Repeated units naturally vary in duration and amplitude, while preserving long-range choreographic structure. Here is a short example. Notice how the generated motion follows the music rhythm, while recurring movements remain recognizable but not simply copied. In summary, we decouple generation into atomic movement planning and motion completion, mirroring a human choreography workflow. This improves musical alignment, structural coherence, motion quality, and fine-grained interpretability. The model and the code has been made available to the public. Thank you for your attention.